Hello everyone. So in this video I'm going to go over two problems from end of chapter 3 that is based on what we have learned until this point. So first one is problem 4.3.4. In this problem we have 3 point charges available, Q1, Q2 and Q3, that their locations are given to us. So if you look at Q1, Q2 and Q3, you see that for all of them Z is actually equal to 0, which means that we don't have any Z dimension for any of our point charges. Therefore, for drawing the points, it would be easier here to just draw the X and Y axis, because then since we don't have the Z axis, it will be easier to look at it this way. So what I'm going to do, I'm going to just take this Z out, and then this would be my y-axis, this would be my x-axis, right? So before we had the 3D, so in the 3D, you remember that this was how our axes would look like. This was z-axis, this was x, and this was y, right? So now I just am going to take z out, and then I'm going to look from the top of this 3D axis. So I'm going to see this 2D axis that I drew down here. Now, if I want to put the point charges that I have in the places that they gave us, so Q1 is at 0, -3, 0, which is -3 is our y, right? So this is our y. So -3y is 1, 2, 3. So that's -3. Therefore, this will be our Q1. And then Q2 is 0, 3, 0. So it has a y equal to 3. 1, 2, 3. So that's my Q2. And my Q3 is 4, 0, 0. That is x. So we have 1, 2, 3, 4. That's 4. And this is my Q3. Now, part A, we want to find the total force acting on the charge Q3. All right, so at part A, we need to find the total force that is acting on charge Q3. So we have two more charges, Q1 and Q2, and they are both exerting some force on point Q3. So we have F13 as the force that is exerted on Q3 based on the existence of Q1, plus F23, that is the force being exerted on point Q3 due to the existence of Q2. And now here you see that for all of the forces that we have, this is 4 nanocoulomb, for all of the point charges, we have 4 nanocoulomb, 4 nanocoulomb, and 1 nanocoulomb. So they are all positive charges. Therefore, they all have the same polarity, which means that the force will be, the direction of the force will be defined based on the polarity of the point charges, right? So if I want to draw the force that Q1 is exerting actually on Q3, Q1 on Q3, this would be my F13, and then my F23 is the force that is being exerted on Q3 due to the existence of Q2, and that is F23. So I have F13 and F23, and now I want to find the total force that is acting on Q3. Now, one thing that you can look here is that if you look at the numbers of Q1 and Q2, they both have the same charge, right? And they both have the same distance from Q3, right? Q3 is at 3 AY, Q1 is at -3y, right? So this means that the force that they are actually exerting on Q3 is the same. They have the same value, only in different directions, right? Now, let's look at something that we haven't seen before. So I'm going to draw this with another color. Force F23. Do you agree that this force consists of these two components? So this one is F23 in the X direction. This is F23 in the Y direction. Same thing is true for F13. So in F13, we can say that F13 is F13 in the X direction and F13 in the Y direction, right? Now, you can see that F13 in the y direction and F23 in the y direction, they are in two different directions, right? So they will cancel each other out because they have the same value. So this will give you a hint that your F total for Q3 should only have the X component, because there is only the force that's exerting on Q3 is only available in the X direction. But let's see if that is true. So let's go over finding F13 and F23 separately, and then see if X will be gone. Sorry, Y will be gone. All right, so F13, we know that F13 is Q1, Q3 over 4 pi epsilon naught R13 to the power of 2, A13. Now, R13, A13. If you look at R13, this is this dark green is R13. This pink one is actually R23. So R13, you can see that it is consisted of these two vectors. So let me actually bring another color here that we don't have. Let's see, this one is good. So this is one vector. This is the other vector. So these two, the addition of these two, the sum of these two, is actually making our vector R13. So that is 3 AY plus 4 AX, right? So now here A13 will be equal to 3 over the magnitude of R. Magnitude of R, let's actually find it real quick here, is the square root of 9 plus 16, that is 5. So it's 3 over 5 AY plus 4 over 5 AX. Okay, now I'm going to just substitute in this equation that I had. So Q1 was 4 nanocoulombs, so it is 4 multiplied by 10 to the negative 9 coulombs. Multiplied by Q3 is 1 nanocoulomb, so it is 1 10 to the negative 9 coulombs, over 4 pi multiplied by epsilon naught, that is 10 to the negative 9 over 36 pi, multiplied by R13 to the power of 2. R13, we found it as 5, so it is 5 to the power of 2. This multiplied by 3 over 5 AY plus 4 over 5 AX, right? So now if you do the calculations here, the calculation for this F13, my F13 will end up to be 1.15 multiplied by 10 to the negative 9 AX plus 0.86 multiplied by 10 to the negative 9 AY. This is my F13, but now I have to find F23 and then add them together to find F total. So let's find F23. F23, the same exact procedure. So we have Q2, Q3 over 4 pi epsilon naught R23 to the power of 2, A23. I'm going to find R23, A23 over here. So R23, A23 will be equal to. If you look at R23, you see that we have a component going this way and then a component going down, right? So what are we going to have? We have the same X, but then our Y is reversed. So our Y is actually negative, instead of 3AY is negative 3AY plus 4AX. But everything else is the same. Okay, so the only thing that is changing here is actually my y component. So if you like substitute everything that you have here in the F23 equation, you should end up with 1.15 10 to the negative 9 AX minus 0.86 multiplied by 10 to the negative 9 AY. And both of these are in newtons, the unit of the force. Now, if you add these two up, you'll see that the AY components will be canceled out. So we are just left with the AX's components. So F total on Q3 is actually F13 plus F23, and that is only 1.15 plus 1.15. That will give us 2.3 AX nanonewton. So the reason that I said nanonewton is that I just factor out the 10 to the power of negative 9. Okay, so you see that my F total, the force that is being exerted on Q3 due to the existence of Q2 and Q1, is actually just having the X component, which we were expecting to see that. Okay, now let's go to part B. Part B, it says that repeat the problem after changing the charge Q2 to negative 4. So let's go here. I'm going to draw this again, draw the points again, because this time my Q2 is actually negative. So this is my X, this is my Y. Q1, we said that it is at 0, negative 3, so 1, 2, negative 3. This is Q1. Q2 is at 0, 3, so 1, 2, 3. You see the points didn't, the location of the points didn't change. And Q3 was 1, 2, 3, 4 on the x-axis. Q3. The only difference this time is that the force that is being exerted on Q3 due to the existence of Q2 now has the other direction, because Q2 now this time is negative while Q3 is positive. So the force this time will be in this direction. So this one is now F23. But what about F13? F13 is still in the same direction because they're both positive. So we have F13 this time. Now let me put this F23 up here. If I add these two vectors, what component am I going to get? I will just have the component of AY, right? So this means that this time if I find these forces, I should only have the component AY. Now the only thing that is different here is the value of Q2, which is negative 4. So Q1, F13 will not change. So F13 will remain at this number. So I'm going to just write it over here, that F13, because nothing there changed, right? So it's 1.15 AX plus 0.86 AY nanonewton. F23 is the one that is changing, but how is it changing? So F23, all the dimensions and everything is the same. The only thing that changed is this Q2. So Q2 is changed to negative 4 instead of positive 4. So do you agree that this F23 will be only multiplied by a negative sign? So then F23 will become the negative of the F23 that we had before. So that will be minus 1.15 AX plus 0.86 AY nanonewtons. Now the F total, the total force that is being exerted on Q3 will be what? F13 plus F23. And you see that clearly the X components will be cancelled with each other. So that's 1.7 AY nanonewtons. So you see that when we change the polarity of one of these components, the whole force will change the direction. Okay? Now, the last part of this question, part C, is actually asking for the electric field intensity at the location Q3 for parts A and B. So part C, we have E due to part A. That is the F total that we found in part A over Q3, because we are finding the electric field intensity at the location of Q3. So if you look at the question here, it says at the location of Q3, right? So then that would be F total over Q3, and that would be 2.3 multiplied by 10 to the negative 9 AX over Q3 was 1 nanocoulomb, so 1 multiplied by 10 to the negative 9. And that would give us 2.3 AX volt per meter, which is the unit of the electric field. And E for part B is the F total of part B over Q3. And that was 1.7 AY over, this was 10 to the negative 9, and then 1 multiplied by 10 to the negative 9, so that would be 1.7 AY volt per meter. Okay,